This is yet another interesting and unique feature in the syntax of AUX, Replicator, ... We talked about compound operators in the last video. In summary, the operation applies back to what you have on the left-hand side, so you don't have to type the same thing again on the right-hand side. You may wonder if we really need to use a compound operator. If the statement is simple enough, you don't have to use it. For example, if the statement is x is equal to x at -20, but if the name of the variable is long, then you probably don't want to type it again. You start to appreciate the compound operator, but you may still say, yeah, I can make the variable name short and sweet, so I'm okay. Then how about this? This is not just the variable name. Sometimes you have complex operations and expressions on the left-hand side. You probably don't want to and probably shouldn't type it again on the other side. So the essence of compound operators is whatever you have on the left-hand side, you are making some modifications or updates to it. That's when you should use compound operators. In other words, the meaning of a statement with a compound operator is that we are updating the content of left-hand side. There's no reason not to use a compound operator. In this example, the statement whatever at -3 means decrease the RMS of whatever by 3 dB. Now the replicator ... What is it? Conceptually, it is an extension of compound operators. This is not just for the use of operator though. This allows you to replicate anything and everything on the left-hand side into right-hand side. Example, you have this expression x is equal to x plus 30. Then you write x is equal to ... plus 30. For this one, you may say, isn't this the same as x plus equal 30? Yes, this is the simplest case and either way it works. How about x is equal to 1 minus x? Then you can't use the compound operator anymore. Use the replicator instead. X is equal to 1 minus ... Again, if the variable name is x, then why bother? You get by without compound operators or the replicator, but imagine you have the variable name long and cumbersome to type again. Now, another example, this is not a simple arithmetic operation, but we are updating the variable x with a function, sqrt, square root. Then just write x is equal to square root of ... Squeeze more room for one more, guess what? X is equal to ... sqrt. Do you get it? The first two dots are for the replicator, and the third one is a dot operator, simplifying for parentheses in function calls. Let's look at some other examples. First, I want to take a part of the array and apply a quadratic equation to it and update. Then use the replicator instead of typing x of 3 to 7 2 more times on the right-hand side. For a side note, the use of replicator makes the coding more efficient because if you type this expression, the AUX interpreter will compute it whenever it sees it. If you use replicator, you avoid this repetitive computation. Second example, I want to extract a part of x and update x with it. Then x is equal to ... and the range. A third example, a kind of extension of the second example. If you have a cell array and you want to update x of second cell with only a part, then do the same. X of cell 2 equal to ... and the range. Another example, a very practical one. By now, you'd understand what this means. X from time point 1 to time point 2 is equal to ... sqrt. With this, we update x from t1 to t2 with a square root function. Wait, if you wonder what's going on here, because you are not supposed to apply square root function to something negative, and the audio signal contains, of course, negative values. Just move on for now. I'll cover this in another video. This is another great flexible feature of AUX, letting you apply mathematical functions to audio signals. Let's look at examples in the AUXLAB screen. First, I'm opening a WAV file. Double-click this line from the command window. Open and play it.
Kite.
I want to modify this portion, K-sound. The time points are from 45 to 125 milliseconds. I'm applying a square root function to make some distortion. Then x from 45 till 125 is equal to ... square root. See how this portion changes. Play.
Kite.
Now, I want to manipulate the last consonant, T sound. Check the time range. It's from 450 milliseconds till the end. Let's try something new. ... minus right angle brace. It's like right arrow. And give it a -5,000. This means shift the spectrum down by 5,000 Hz. so it should make some dramatic changes. Let's hear this part. It's definitely different. It's more muffled. Now play the entire word again.
kite,
Let's compare it with the original recording. Here I am just bringing up the wave function followed by dot play.
kite,
And the modified version.